video is to help you understand phase shifts when graphing the sine, not phase shifts, vertical shifts in amplitude when graphing the sine function. So let's go over that. Sometimes your teacher is going to ask you to graph the general function y equals a sine of x plus d. So what's important about this is this a value right here represents the amplitude. Amplitude just means the distance from the middle to the top or from the middle of your graph to the bottom of your graph. And d is going to represent the vertical shift. One strategy for graphing these types of problems is first determining what your minimum value is and what your maximum value is in your sine and cosine functions. So what I'm going to do is I'm going to make a little list here. You want to memorize this list of formulas as well as be able to apply them. So the first thing you need to recognize is what is the vertical shift. In your formula, it's just equal to your d value. So it would be whatever this number is right here. Let's do a real example so it's not so obscure. So let's say y is equal to 2 sine of x minus 3. So since it's normally equal to your d value, in this case we can see that d has been replaced by a negative 3, where d is here, a negative 3 is here. So my vertical shift would be a negative 3. The next thing you want to be able to identify is the amplitude. Well, we can see in the previous example above that the amplitude is just whatever the coefficient is in front of the sine. So in this case, it's a 2. So my amplitude, I'm just going to write it as AMP, would be equal to 2. Now, how can we use this information to find what the maximum and the minimum value is on our graph? The way that you find the maximum is going to be equal to your vertical shift. So I'm just going to write this as vertical plus your amplitude. And your minimum is going to equal your vertical shift minus your amplitude. So in this particular problem that we have right here, our vertical shift is negative 3 and our amplitude is 2. Therefore, our vertical shift plus our amplitude would be negative 3 plus 2, or negative 1. And what about our minimum? Well, our minimum is equal to our vertical shift minus our amplitude, so that would be negative 3 minus 2, which would give us negative 5. The next thing that you need to know is how to recognize what the period of your function is. In future examples, it's going to be different, but for now, it's just equal to 2 pi. So that's going to change in future videos, but for now, your period is just 2 pi. We'll describe it in different terms later. Now, how do you figure out your scales? So how do I figure out my y scale and my x scale? Well, your x scale is always going to be equal to 2 pi over 4. I'm going to actually write this as the period over 4. In this case, the period's 2 pi, but that might be different later. So it's going to be your period over 4. So in this case, that's equal to 2 pi over 4, which is therefore pi divided by 2. So that's my x scale. So I'm going to go ahead and draw that in right now. So that would be pi over 2. That would be 2 pi over 2, which is just pi. This would be 3 pi over 2. Make that over a little bit more. And this would be 4 pi over 2, which is just 2 pi. And on the left side, you're going to have the same setup. Negative pi over 2. Negative pi. Negative 3 pi over 2. And negative 2 pi. The next thing that you want to do is you actually want to draw in lines where your vertical shift is, and as well as where your minimum and your maximum values are. I'm going to make this not drawn to scale because I want to avoid all of these negatives in here because I think that's going to make it confusing. So I know this doesn't make any sense, but I'm going to put negative 1 right here, and I'm actually going to extend this line here. I'm going to extend that there. So that I can go further down. So there's that negative 1 on the top. I'm also going to want to draw, we'll do scale here. So this would be negative 2. this would be -3, this would be -4, and this would be -5. What you want to do next is you want to put little dotted lines where your maximum value is, where your minimum value is, and where your vertical shift is. So I'm going to go ahead and draw those in right now. So these right now are my dotted lines for my maximum at -1. Down here, I'm going to put dotted lines for my minimum, which is at -5. And here I'm going to put dotted lines for my vertical shift, which is at -3. The next thing to know is that anytime you have a value that deals with sine, it always starts in the middle. So what I mean by that is on the y-axis, I'm going to be right here in the middle. So I don't start at my max, I don't start at my min, but rather I start at the vertical shift when I'm on the y-axis. Again, this is something that's going to change later, but for now it's good practice to recognize that. Sine also goes up. So the reason I've made the scale the period divided by 4 is because what you're going to be able to do is actually place points alternating on these different scale marks on the vertical shift, the line for the max, or the line for the min. Since it's sine, I'm going to go up. So I'm going to put a little dot there at pi/2. Well, pi/2 comma -1. So we know -1s are max, so we really can't go any higher. So the only way to go is down. So as I go to my next mark on my scale, this pi mark, I'm going to go back to the vertical shift. I'm then going to continue through to the minimum and then back up there. So it essentially alternates. As I move along my scale, I'm alternating between the middle, the vertical shift, the top, the max, and then back to the middle and then down to the bottom. So the pattern goes middle, top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, and that just keeps continuing. And you can even extrapolate it back the other way. So here I had at pi/2, I was at the top. At 0, I was in the middle. And so at -pi/2, I'm going to be at the bottom. So it follows that same pattern. And that's how we want to get our sinusoidal graph. When you connect these points, you don't want to do so with jagged edges. So you don't want to make little triangles out of this. But rather, you really want to curl it at the top. So I like to think that I'm coming really steep through the middle and then kind of wait until the last minute and break it like that. And you want to keep, and then start to break it. And then keep, break it. And then it keeps, and then it breaks and goes really steep through the middle, and then it rounds at the top. Rounds at the bottom. Rounds like that. So that last corner wasn't too good. A couple mistakes in here. It's really hard to do this on a computer. But you can see the general idea. These aren't connected with rigid structures. So just to recap really quickly, I'm going to run through everything once more. So what did I do first? Well, first, I identified what my amplitude was. And my amplitude was just this front number right here. In our example, it was 2. So my amplitude was equal to 2. My vertical shift was -3. I recognize that because it's whatever's tacked on to the end of the function. My max is equal to my vertical shift plus my amplitude. So in this case, that was -3 plus 2 gave me -1. My minimum is my vertical shift minus my amplitude. So in this case, it's -3 minus 2, which gives me -5. For now, the period is always 2 pi. And the period is defined as the amount of time it takes to do one full cycle. So I don't think I explained that well earlier. From here to here represents one full cycle. We can see it's going all the way up, all the way down, and back to where it started. Your x scale is equal to the period over 4. Since the period here is 2 pi, your x scale ends up being pi/2. The reason you do this is it allows you to alternate your points between middle, top, middle, bottom, middle, top, middle, bottom, where the middle, top, middle, bottom refer to the max, the min, and the vertical shift. And it makes graphing so much easier. So this was the first example. I'm going to do another example of sine in the next video, and then I'll do a couple with cosine, and then I'll have a video distinguishing the differences. So please continue and watch the next video.